This is a few review exercises for your week 9 DCA. Write your notes on page 35 of your notebook. The first thing we're going to discuss is parallel lines and perpendicular lines. Parallel lines have the same slope. For example, the lines y equals 4x plus 5 and y equals 4x minus 12 are parallel. They both have 4 as their slope. The lines y equals negative 1 over 2x minus 4 and y equals negative 1 over 2x plus 2 are also parallel because their slope is negative 1 over 2. Perpendicular lines, however, have lines that are slopes that are opposite reciprocals. Opposite reciprocal means change sign and flip. So line y equals 2/3 x plus 1 and y equals negative 3 over 2x plus 5 are perpendicular because 2 over 3 is the first slope, and then when you change the sign that becomes negative and you flip it, then the 3 goes on top. So that's what we mean by opposite reciprocal, change sign and flip. The second example, y is equal to 3x plus 5, so the slope is 3. And then the opposite reciprocal would need to be a negative and flip, so 1 over 3. Because truthfully, this first 3 is written as 3 over 1, but the 1 is understood. So you know when you flip it, you got to put the 1 on top. So this first question wants us to write the equation of a line that is parallel to the given line and passes through the point. So the slope of the given line is 7. The y-intercept of the given line is negative 5. So in order for the line to be parallel, they have to have the same slope. So automatically, I can get rid of choice A and B. Now, when I look at choice C, it says plus 3, indicating that 3 is the y-intercept. But in order for 3 to be the y-intercept, the point would have to cross, the line would have to cross the y-axis at 0, 3. So our given coordinate 2, 3 would not work. So we can cancel out C as well. So that means our answer choice is D. To verify, what you could do is substitute the given x and y coordinate into the equation to get a true equation. So this is another way to check your work. So for example, the y value is 3, so we'll put 3 here, equals 7 times x is 2 in the given point, minus 11. So 3 is equal to 7 times 2 is 14, and then 3 equals 14 minus 11, that's also 3. So yes, it checks out. On number 2, we're going to write the equation of a line that is perpendicular to the given equation, y equals 7x minus 5. So it's the same line as above, so the slope is, again, 7, and the y-intercept is negative 5. In other words, 0, negative 5. This time it wants the equation to pass, the line to pass through the point 14, 4. So we can immediately eliminate the lines, the equations that have the same slope, because perpendicular lines are not allowed to have the same slope. They have to be opposite reciprocals. Opposite reciprocal, again, means to change the sign and flip. So right now, the sign for our slope is positive. So that means for the perpendicular, our slope needs to be negative. And then we need to flip it. Right now, it's 7 over 1. When I flip it, it becomes 1 over 7. So we're looking for the equation where the slope is negative 1 over 7, which happens to be both A and B. So now to determine which one would work, we would have to substitute the x and y coordinate into the equation. So let's do that. So the y coordinate is 4, and we're saying it equals negative 1 over 7 times our x coordinate, which is 14 plus 7 for the first equation, or for A. So let's see, 4 equals negative 1 over 7 times 14 would end up being negative 2. And negative 2 plus 7 is positive 5. So this one doesn't check out. So A doesn't work. So that must mean our answer is B. But let's just verify that there are no mistakes on this test. So again, our y value is 4, negative 1 over 7. Our x value is 14 plus 6. So 4 equals, again, negative 1 over 7 times 14 is a negative 2. And then negative 2 plus 6 is 4. So yes, B does check out. Now let's talk about dilations. Dilations are going to be enlargements or reductions. In other words, get bigger or smaller. It'll be an enlargement if it is greater than 1, and a reduction if it is less than 1. So enlargement, greater than 1. Reduction, less than 1. The scale factor will be the number that is either greater than 1 or less than 1. So in this example, they want to know if I go from P to P prime, P always will be the pre-image. So whenever a capital letter is just a normal capital letter, that's the pre-image. And whenever it has the apostrophe, that's the image. So going from the pre-image to the image, what dilation occurred? Well, clearly, P, the pentagon with P on it, got larger. So it is an enlargement. Now it wants to know what is the value of x. Well, when I look at the total distance of this side here, it is 16. And I already know there's 12 of it right here. So that means x has to be 4. Because 4 plus 12 would give you 16. Now it wants to know what is the scale factor. In other words, what number causes P to enlarge to so much? So to go from 4 to 16, what number would you multiply? Exactly, you would multiply by 4. So the scale factor, which we sometimes call K, would be 4. Why? Because 4 times 4 gives you 16, which is the image. Now, in this case, the girl, the pre-image, is big, and the image is small. So this would be an example of a reduction because, again, this is our pre-image here, and it got smaller, so it's a reduction. The value of x, well, if the total length is 15 and you already have 10 here, so that means x has to be 5. Because 5 plus 10 would be 15. So now they want us to find the scale factor. By what number is it reducing? And if we go back to earlier, we said a reduction has to be a number less than 1. So it's going to be a fractional number. So what number would I multiply 15 by that would produce 5? Well, 15 times 1/3 would give you 5. In other words, 15 divided by 3 is 5. So the scale factor is 1/3. Work this example out with the Statue of Liberty on a separate sheet of paper and snap a photo. 1A. Let's talk about translations. Which two directions does x represent? Well, when you look at a coordinate grid, x runs horizontally, and when you're running horizontally, you're going left or right. Now, what direction does y run? Well, y runs vertically, and when you're running vertically, you're going up or down. I'll just do a few of these. You need to be familiar with this notation. So if you take your x's and you add a value like 3, whenever you add to your x's, you're moving to the right because you're increasing. So when the first one, x is increasing by 3, so moving right 3. Your y's, however, are decreasing by 5, so when your y's decrease, it moves downward. So you need to move right 3, down 5. So that would be C. In the second one, x is decreasing by 5, so when x is decreased, that's going left. The y's are also decreasing, but by 3, so when y decreases, it goes down. So that would be 5 left and 3 down, so D. Again, you need to be familiar with seeing this notation. If I go back to this previous notation, this notation is what we consider motion rule. So all of these are written in motion rule. In other words, you're giving the directions or a formula for how to create the transformation. So on these next few examples, you have the image and the pre-image and the image, and they want you to write the motion rule that caused the new picture. We will continue this lesson in just a moment.